Hi, everyone. Here we are for a new session on the Almudena track. So right now we have Aleks Seovic. I'm going to say it wrong for sure. So please correct me afterwards. And Dmitry Alexandrov. So these fine folks come from Oracle. Aleks is also the Coherence architect over there. And they are going to talk to us about building scalable microservice for Java using Helidon and Coherence. So guys, go for it. We'll see you later for the questions.
Okay, so probably I should start. So Aleks Seovic, yes, and Dmitry Alexandrov. Okay, so lovely to be at least online with you this evening. Hopefully next year in Portugal. I've really never been there, and I really would like to be there. And today we're going to make a very intense session about how to build scalable microservices for Java with the product I'm working on in Oracle Helidon and the another great product, Coherence Community Edition, which is presented by Aleks Seovic. So we're going to be like not two parts, but two main baselines, two main streams of talk, and I hope you will like it. So safe harbor statement. This will be fast, but anytime you do business decision, please check once again. So let's start. So Helidon. What is Project Helidon? So we call ourselves a set of libraries for writing microservices. You can find more information on our official site, helidon.io, but actually you would probably ask yourself what Helidon is. And in Greek, it means swallow. It's a very fast, nice, maneuverable, awesome bird, which lives in flocks, and every time it flies in this flocks, it reminds us of microservices and all this microservices world. And I believe the name was chosen really cool because well, it simply reminds us what a microservice should be: really fast, really maneuverable, really still oriented in this well, maybe chaotical world, but still with its own rules. So swallow is a perfect word for such a project. So the best part of it, I would say, so first of all, it's awesome, but even better, it makes it that it's Apache 2.0 license, one of the first Oracle products which is under this license. That means that the code is there, the issues are there, we accept PRs. It's a community project. That means that it's not only us working on that project, it means that there is a community working on that project, and that means it really makes it community driven, and that's why it developed so nicely. So the main idea that is built on top of Netty, which is makes it really asynchronous and very, very fast. And once again, we are cloud native ready. That means that whenever you run your microservices, it doesn't mean that you just go to some REST endpoints and you have them. From the box, you have health, tracing, metrics, everything you need to run your microservices in cloud environments. And one of the best things, of course, is that many other frameworks are just getting to native image support, and we are supporting it from almost very beginning. That means that our support for GraalVM native image is approaching 100%, and everything we do is Graal native image aware, and at the end it comes really native image compliant. So we are really working on that hard on that. And one other thing what makes this really cool is that we don't have any legacy with Java 8 world. So we are Java 11 plus world. That means that we enjoy all the benefits which came to us beginning from Java post 9 world. That means we are modular. We are enjoying many new technologies that came there. And our main goal is not to keep the version low. So our main goal is exactly the opposite, to keep the version really high. That means that we try to get rid of everything which is legacy, and we try to put only new stuff. So now as Java 17 comes, believe me, there's big work we're doing to adopt everything from there and you to enjoy the best, all the benefits that Java 17 brings you. So let us take a look at high level of the architecture, what Helidon actually is. So as I said, we are built on top of NetT. It is asynchronous, and all the services around it are wrapped in so-called reactive layer of Helidon SE. We'll come a little bit later there. But to serve you well, to make it really, really standard and portable, because standard means much to us, we are into standards. That means that we are doing everything possible to comply to the standards, and we are like, we try to do the best to be standard. That means that we are portable. That means that you can migrate easily to us. So then comes the MicroProfile layer. That means that all the MicroProfile specifications are implemented there, and we are like MicroProfile based framework. So this is like on the top, and this is like something which solves 80% of your demands. So let us actually jump in a little bit for people who actually don't know what MicroProfile is. Just 2 slides. It's an open source community specification for enterprise Java microservices. That means that it's not implementation. It's just a specification that you have to implement. It is now hosted under Eclipse Foundation. It was born mainly on our eyes because it's like 4 years old, when several participants like Oracle, IBM, Red Hat, Dmitry, and even Microsoft sat together and said, we need a specification for microservices to make them portable, to make them standard, and to make them like, exactly industry standard. And with high cadence of 4 years per year, so several specifications are released, and these specifications actually, now it already started with 3 specifications like CDI, JSONP, and JOX-RS. Now there are 12 main specifications. You see, each of them evolves at its own speed. So there's open tracing for tracing, which is version 2.0, and health, for example, which is 3.0. It evolves a little bit faster. That means that this 12 specification actually fill most of the demands that are for running microservices and the clouds, and make them really useful. That means that you have fault tolerance, but you got these configurations, so even the configuration is portable. We care for the health checks, for metrics, for telemetry, for delivering it to you. And this is actually, those 12 specifications are the core, and we do implement it. Actually, what we do implement is that we implement some MicroProfile specifications, as you will probably see from this side. We are for the delivery for this Helidon, which you actually get as a product. We also implement several specifications like from Jakarta, as you probably see here. So there's like annotations, transaction persistence. We also do this, so get out of the box. And since we have some great demand of course in gRPC, we still deliver it to you. And now there is MicroProfile specification like GraphQL and several other specifications like long-running actions that are not part of this 12 specifications I showed you, but this one is also delivered to you. So we are really proud of the fact that we fully support CDI, even in native environment. That means that it's not like a semi-support or not a partial support. We have full CDI support both in Java world and both in native image world, so which makes this really cool. Just a few words about Helidon SE. If you remember this layer, which is like intermediate layer, we decided actually not to hide it from our users, but to give you a so-called Backstage Pass. So you don't need to have to code in MicroProfile to get all the same functionality that you have there. So you have still config security, health check, tracing, metrics, everything, but you are able to do this in pure Java, and you still receive even more benefits like reactive stream, reactive messaging, and DB client, which is also we're proud of it because it makes your synchronous drivers work asynchronously with some magic that we provide. And you still are able to do this in pure Java. What does that mean? That means that like MP style on your right is done with annotations, and on your left you get the same result, but without any magic, without any additional managing stuff. You get in pure Java, and it works like way faster. So just an interesting time. This is all you need to know for Helidon right now. And I will give the word to Aleks. Aleks, go ahead.
Well, thank you. For those of you not familiar with Coherence, I'll just go briefly over what Coherence is and why you would want to use it, and then we'll get to the demo, which I think is the most interesting part of the presentation. So, a number of years ago, somebody said that Coherence is the world's most expensive hash map. And it was funny because it was partially true at the time. It was a hash map and it was fairly expensive. But the good news is that it's now free. I mean, we open source Coherence Community Edition last year in June. So we're going to be releasing our 2106 update this year. We're doing releases every 6 months. So we are about to come out with a new release. And that's kind of what we are showing. Some of the features that we'll show in the presentation are going to be available in the next few weeks. Next slide, please. So what is Coherence? Coherence is the first in-memory data grid. It created a space back in 2001, so it's about 20 years old now. But even though it's 20 years old, it is very well suited for modern cloud applications. One of the reasons for that is that Coherence was always designed to scale out. It was always designed to build distributed systems. And that's kind of what modern cloud applications are. They are distributed systems, and Coherence helps you build those types of applications. It is also a Java library, so it's very different. I mean, it is a data management technology. You can compare it to Mongo or to Redis or to any database if you wish. But it's, on the other hand, it's the way you use it, it's more similar to an embedded database, something like H2 or Apache Derby or something like that, right? So you can embed it into your application, but it's not limited to tests and some simple examples where you would run an embedded database, because it allows you to scale out across many servers, many processes. It will cluster together. It is fault tolerant because any of the components can fail and your data is still safe, et cetera, et cetera. But from the usage perspective, it is just a library. You embed it into the application and you use it. It is also easy to deploy and scale in Kubernetes using Coherence Operator, which is something we'll be showing in a demo in a few minutes. And we have built-in support for monitoring with Prometheus, Grafana, and Jaeger. So you can use open tracing to see how your requests are being processed. You can look at the coherence metrics in the Grafana, et cetera. And as I said, we've had open sourced edition since June of last year. Next slide, please. So in many situations, people say, I want to use Coherence for caching. And yes, Coherence is distributed cache. That's how it started. That's what it was designed to do initially, but it's actually a lot more than that. At the basic level, it is scalable, fast, persistent, general purpose KV data store. Cache implies that you can lose data. Coherence can certainly be configured to work that way, but it can also be configured not to lose data. It stores data in memory for fast access, but it also optionally persists it to disk for durability. So if you want to have persistent data, you can easily accomplish that. It's basically just a flag that you switch. It partitions data across many cluster members to improve both system capacity and throughput. Obviously, the more members you have, the more data you can store and the more requests you can process in parallel, because we'll do everything we can to parallelize requests across the cluster. It creates backups of your primary data copy as far away as possible from the primary data, which is very important in the cloud, because you don't want to lose data if something fails. So at the basic level, Coherence is aware of topology of the cluster, so it will always create backup copy in a different JVM. But those JVMs may live in containers, and those containers may live on VMs, and those VMs are on some physical servers, which are in some data center, some availability domain in the cloud. And Coherence is aware of all of that. So you can configure it to back up as far away as possible, which means that for any primary copy of the data, if you have multi-AD deployment in the cloud, we can actually ensure that the backup is created in a different AD. So if your availability domain fails, your data is still safe. So you can, you have that degree of fault tolerance that is, somewhat driven by the product itself. Some things need to configuration. The good news is if you're running in the cloud, our Coherence Kubernetes operator will configure everything for you, so you're safe, even if the whole availability domain fails. And then from a functional standpoint, it's not just gets and puts. We also support queries, aggregations, in-place processing of the data, and we'll show some of those features in a demo in a minute. Next slide, please. It is also an event streaming platform, and there are a couple pieces to it. I mean, we've always had server-side and client-side event listeners, so you can actually react to data changes in any shape or form. So you can, when a new object, when a new entry is inserted into Coherence, you can react to that. When it's updated, deleted, and you can do it both on the server side, which means that the code that you want to execute will execute only on the member that basically owns that piece of data, that owns the primary copy of the data. Or you can do it on the client side, so anybody who is interested in the change can react to it. And that's typically used by customers to update UIs in their desktop applications. Like if you're looking at a stock portfolio and you want to update positions as they change on the server side, you can actually do that very easily using client-side events. And then more recently, we've also added topics which allow you to do pub/sub messaging. So you can basically have publishers and subscribers publish messages to topics, receive messages from topics, et cetera, et cetera. So it's all built on existing Coherence primitives. So, it's a new feature, but it's built on something that's been around for a very long time. So, and has been tried and true in production. Next slide. And finally, yes, we can do caching as well. I mean, a lot of the caching options that you may be familiar with kind of were invented to some degree by people working on Coherence. You can do partition or replicated caches, time or size limited. Obviously, this wasn't invented by Coherence. This has been around for a long time. But then there are some things like read-through, write-through, which allow you to integrate your caches with backend data stores and to automatically update data stores or insert data into the cache transparently. So you don't have to do a lookup. You don't have to look up in a cache, and then on a cache miss, you go to the data store and then you put the thing in a cache. You can basically have the cache do that for you. So on a miss, we'll automatically go to the database and get the data, for example. We can also do client-side caching. So you can bring data closer to the client to optimize your read performance by using continuous query caches and near caches. So, those caches will be kept in sync with the backend cache using events. So as the data in the backend changes, the caches will be invalidated or updated depending on which type of the front cache you're using. And live materialized views are basically what I mentioned. You can define a query that says, okay, I want to have subset of the data. I want to have all the positions for this stock symbol, for example. I want to have them in my front cache, and as they change on the back end, that live view that's in your local process will be automatically updated. Next slide, please. So it's time. That's pretty much all I had for Coherence. So let's talk about the demo that we are going to show you. So this is a simple to-do list application. I mean, the functionality is very trivial, but at the same time, it allows us to show a number of features. And I think it's good to start with a simple demo and go from there. The code for the demo is available on GitHub. You have the link at the bottom. And there is also a series of articles. We'll provide a link to our blog at the end of the presentation, but there is a series of articles on Coherence community blog that basically walks you through building this application, building the backend, building the front end, running it in Kubernetes, deploying it, managing it, et cetera, et cetera. So, you can always refer to that for more details, because we can't possibly cover everything in a 50-minute talk. So with that, I'll hand it off back to Dmitry to get us started.
Oh, it looks awesome. By the way, if I remember, there's like Java magazine articles as well, series.
Yes, I mean the copies of those are on the blog.
Lovely.
On blog, so
yeah. A lot of read. It's nice. You should try it. And okay, let us actually create this thing. We will do like semi-live creation of this awesome software. So Helidon may be like the foundation for your microservices. So whenever you need to serve this data via REST and other protocols, it is the way to do it the best. So how to start with Helidon? So we're Maven, oriented people. That means that the only thing you need is just to generate an archetype, which is here, and then just to include one dependency, and you are ready to start working with Helidon. You may also use the MicroProfile starter page, which is you just choose the MicroProfile version, and just choose the right the right framework, and it will generate you the POM file, and you're ready to go. But for our how I say not clients, I would say for the programmers who actually prefer Helidon, we care much in this, but we created a special CLI application where you can receive even more functionality and some code generation to not only initialize your application, but for all the cycle that you develop this application. But let us actually see it in our demo. So we have a console, and to start a project of Helidon, so you just get a brew, get it from the link I sent on the slide. Just get the application, and you just type Helidon in it. So it is available for all platforms like Linux, Mac OS, and even Windows now. So Helidon, I got Helidon in it, and like in our it looks for the latest version, so it's very cool. And that means that if you remember your childhood, you just answer a few questions to the console. So this was the first application I always wrote, and it will get you something useful. So as you probably see, we have two flavors, which is SEMP. We'll create the MicroProfile version of it, and we will use like a quick starter, which we will then transform to the application. So you just enter project name, group ID, artifacts ID, versions, package name. So we'll keep defaulted in the interest of time. And the last question is like start development loop. What is it? I will show you a bit later. So, and we are actually done. So we will use our favorite IDE to actually start it. So I hope it will be like fast right now. So it usually, well, when you stream something, it is always like a little bit slower than usual because Zoom takes a lot of your resources. So this is an application which was generated for you, and you see it always starts with a very nice README. So you will be able to see how it works and what you should have. Well, let us jump into it and see what we have. So we have only two classes, and this is absolutely sufficient to run your resources. It's like a greeting application. It will greet you. And what we have, so first of all, we have a greeting provider, something like, sends you greetings, like getting the greeting messages, which we will then inject into our greeting resource. And as you may probably see, this is a very familiar annotations. These are very familiar annotations for everybody who codes in MicroProfile way. That means that we are standard. That means you can easily migrate your application to Helidon because it's standard. Okay, so we will create, so it actually created us a greeting resource, which is request scoped. It injected us our, greeting provider. So full CDI support, as I say, and there are a few messages like default, etc., etc. But once again, this is not so interesting. We don't need it right now. We need to create task applications. And we will just delete everything we have here, and let me jump into it. I have, just in the interest of time, I have created like an initial service that we're going to implement. So first of all, task is the core. Task is something which is, which we are going to manage with our management application. And it is like a POJO, a usual POJO, which has like 4 fields. And for the next thing, we are going to do a service who manages this. It's like an abstract service because we are going to serve this this data in 3 ways. We're going to make it in REST, gRPC, and GraphQL way, and you will see how easy it is. So once again, we have, for now, it returns nothing because Aleks will then take over and fill in those methods with right usage of coherence. So we will create a task. We will get all the tasks. We find task, we delete task, we delete completed, we update description. So this is enough functionality, which is we are going to implement. As I said, we want to serve it in several ways. So the first and the most usual way of serving this data is just a REST endpoint. You see, as you probably saw from the quick start, we have a set of annotations, which is a MicroProfile annotation. We say path, we say application scope. We are constructing this object, and then we have several methods like get, post, delete, where we actually reuse the service, the to-do list service, and connect to it, which we simply inject here. So we just inject it with CDI. Absolutely nothing special, we just use it. So as you probably see, regular set of annotation, but as I said, we want to do it not only in REST, we want to do it in for example, gRPC way. So there's another class, which the only thing you actually need to do is to annotate it as a gRPC source, make it application scope, for example. The same way, inject the to-do list service, and then with some different set of annotations, you do almost the same. So you have a memory task which creates a task for you. We'll get, so if you want many tasks, there will be streaming service with tasks. The other applications are just unary. That means that we delete, update, and create tasks. But as I said, we want even more. We want to serve it in GraphQL way because GraphQL is awesome and it's very popular. You just create another class, you just annotate it with GraphQL, and you actually use the GraphQL specific annotations, which are for example, if we do something which is create, we do a mutation. If we just query those tasks, it's just a query with some description. Whenever we change something, it's a mutation. Whenever we query something, it is just a query. So once again, you get all the annotations, and you see the reuse of this class is just awesome. Once again, the only thing you actually need to do is as I said, we are very modular. So you just add the annotation for MicroProfile, for GraphQL, for gRPC, and you are done. So I believe now, as we have the skeleton of all of this stuff, it's now a great idea to fill it in with some caching and persistence. For that, we have Coherence, and Aleks, please take over and show us how to do this. I will stop sharing, and we will continue.
Thank you. All right. So let me just clear my screen a bit. Okay, so as Dmitry has shown you, basically have this to-do list service, which is the meat of our service implementation, and then those 3 facades, REST facade, gRPC facade, and GraphQL facade all delegate to. So let's see what we need to do to implement this. There are actually a couple things we need to make, a couple changes we need to make to what Dmitry has shown to make classes suitable to work with Coherence. For example, task needs to be serializable, but we're not, so we could make it serializable and use Java serialization to store it in Coherence, but we're going to do something different, and we're going to make it the portable type, which is a Coherence proprietary serialization format that is much more efficient than Java serialization, allows us to actually access this class in its serialized form from different platforms, from .NET, from C++, etc. Right? So we're going to annotate the class with that portable type. We're going to annotate the fields that we want to serialize with at portable. And that's pretty much it. We're done with the data serialization requirements. Second thing we're going to do is implement our data access layer. And for that, we're actually going to we're going to define a task repository class. If you're familiar with domain-driven design, this is, or Martin Fowler's enterprise architecture patterns, repository is a typical way to access some entities. In this case, we want to have repository of tasks. And Coherence provide us with a convenient abstract repository class that we can extend in this case. And we only need to provide a couple things. We need to inject the named map, which is Coherence named map that we're going to use to store the tasks. And we need to implement these three methods. Get map returns task, get ID tells us how to return identifier, entity ID from a given entity, from a task in this case. And then we need to know, the repository needs to know what the entity type is. So that's really all we need to do on the repository front. And then we can use that repository to implement our service, right? So we inject the repository into our to-do list service. And then when we call create task, it is as simple as saying task saves, new task, task save, new task with a description. To get tasks, we use Coherence query functionality. So we can define a filter. If Boolean flag is specified, if we are querying for completed tasks or for active tasks, this flag will be specified. If it's null, then we want to see all the tasks. So if the completed is null, we'll return always filter, which will give us all the values, all the tasks back. Otherwise, it will return an equal filter where task get completed is equal to completed flag that's passed in. So notice that we are using, these methods always in equals, they're static methods on the filters DSL class. And the way you construct a task is by basically providing a property that you want to query on. In this case, task get completed using Java method references. So it gives you a type safe way to actually define these queries. And then we call task get all order by. We pass the filter that we want to query on, and we pass the attribute to order by, and that's the creation time. So this will give us back a collection of tasks to display on the screen or to return to the client, right? Find task with a given ID. We'll attempt to find a task with an ID if it, by calling task get. If it finds it, it will return it. Otherwise, we throw not found exception, so it can be handled properly by the REST API, and it will return 404 error code, etc. Right? Similar thing with delete task. We'll call task remove by ID and return the old task because that's what our API defines. So it will return the remove task. If the task is not found, it will throw 404 not found exception. Then we have remove all, which is again with a filter. So if get completed is true, we'll remove all the tasks with that attribute. And then to update the description, we can call, this is actually where things get interesting. Unlike many data stores where your typical pattern would be read, modify, write, Coherence actually allows you to send the update to the node that owns the primary copy of the data. So in this case, we want to update description for a task with this ID. So instead of fetching that task, updating it and sending it back, which is both inefficient and introduces some concurrency issues, we can simply say that tasks update with this given ID by calling this method with this argument. So what will happen here is this whole function will actually be sent and executed on the server. So we will execute set description by passing this parameter to it on the node that actually owns the task with this ID. So instead of bringing data to the client and moving data around, we're actually sending function to the data and executing it locally where the data lives. And it's the same with a completion status. So we update completion status by calling set completed on the task somewhere inside of the cluster. So that's pretty much it. That's our implementation. It's fairly trivial. It's fairly easy API to use. There is a lot more functionality on the abstract repository than I'm showing here. So you can see there are a bunch of there are aggregation methods, there are stream methods, things like that. So it's a fairly rich API that allows you to do most things you would ever want to do with the data access repository class. So there are a couple additional things I wanted to show you. I said earlier that you can use Coherence Events to update clients. And that's exactly what we're going to do in this case. We're going to have 3 clients. We're going to have JavaFX client that uses gRPC API. We're going to have REST client, React application that uses our REST API, and we're going to have GraphQL client. So whenever something changes in the cluster, in Coherence, whenever data changes, we want all of those clients to be in sync. And to do that, we are using events. So in this case, we are, again, injecting task repository, and then we are adding listener to it. And we create a listener that will basically, whenever task is inserted, it will broadcast it to the SSE broadcaster. So for REST API, we're using server sent events to notify the client. And so we notify client whenever task is inserted, updated, or removed. For gRPC API, we do something similar but slightly different, because again, gRPC doesn't have SSE, but it has the ability to stream data back. So we implement server streaming methods in gRPC that again registers listener that will send task inserted, task updated, or task removed event to the client. So now that we have all that, I actually have the application running. So again, I have 3 APIs. The first one is React application. It's actually served by the same server that is running Helidon and Coherence at the moment. The second one is my JavaFX application. It uses gRPC API. And the third one is GraphQL client, which is GraphQL. It's just a basic generic GraphQL client. So if I enter the task in any client here, you can see that both, GraphQL doesn't have support for events, but both React client and JavaFX client are kept in sync whenever I change something. And then I can also query the data in my GraphQL API, and I can see that I'm getting back task 1 and task 2. I can also create data from my GraphQL API, and it should show up. Yep, it took a little bit. So it should show up in the other 2 events. And again, if I modify it somewhere, it should be modified everywhere. So that's basically how it works. You can see, you saw the application. It's fairly simple to implement. The data access API is pretty much trivial. What Helidon gives you, is very, very easy way to support all these different methods, right? You want to do REST, you want to do GraphQL, you want to do gRPC. It's easy to do any of them or all of them, as in this case. So, but that's only part of the puzzle, right? So we have right now the way this works. I basically have a single server and a single client running locally on my laptop. But that's not how you would deploy this application, right? One of the premises of this talk is how do we build scalable applications for the cloud, right? So having a single process is not what's going to get us there. So one thing that we can do now is, remember, because Coherence is just a library, Helidon is just a library. It's all Java. It's all fairly lightweight. So we just need to add a couple dependencies to make this work, right? So Dmitry showed you, you added GraphQL server and Helidon and gRPC server. We need to add a couple of Coherence dependencies. We need to add Coherence CDI server, which provides integration of Coherence with Helidon and allows Helidon to bootstrap Coherence via CDI. We also need to add Coherence gRPC proxy. Well, we don't in this case, but it's a leftover. And then we also add support for MP config, MicroProfile config, and MicroProfile metrics, which will allow us to, allow Coherence to use Helidon MicroProfile configuration, and it will actually send send Coherence metrics to Helidon so they can be scraped by Prometheus. And finally, what we have configured here is a way to create a Docker image from this application. In this case, we are using Jib Maven plugin, and we are using distroless Java 11 image as our base image. We let Jib package everything up into a Docker image. We have the Docker image uploaded to GitHub Docker repository. And once we have all of that, once that executes, everything gets uploaded, we can actually use Coherence operator to deploy this whole Helidon Coherence application into Kubernetes cluster. So this is the deployment descriptor that we use. So Coherence operator introduces a custom resource type, custom resource definition. And in this case, we are calling it, we're calling this to-do list deployment, where we say that we want to start with one replica. We want to create, we want to use this image, which is what we push to GHCR.io. We specify, for demo purposes, we want to sample everything. So it just this configures Jaeger to basically trace every single operation. And then Coherence operator also has special support for Helidon applications because it effectively changes. By default, Coherence operator will use Coherence default main class. But when we say that the application type is Helidon, then it will use Helidon main class and let Helidon bootstrap Coherence internally. And then finally, we also enable persistence. So in this case, when we run this in the cloud, we don't want our tasks to be lost if the cluster goes down. So we want everything to be persisted. So we turn persistence mode to active, and we configure persistence volume claim, in this case to use OCI BV because we're deploying it to OKE cluster in OCI cloud with a 50 gigabyte per block volume. And then we have some JVM settings, just heap size and ports that we want to expose, gRPC on 1408, HTTP on 7001, and we want to enable Prometheus service monitor. So that's pretty much all you need on the Kubernetes side, which brings us to, what do we have? I actually have this already deployed in the interest of time. And right now I have 3 replicas. And you can see that and there are 3 pods, they're backed by a stateful set. And basically every pod has a PVC attached to it. So that's fine. And if we look in, oops, and this application is running, it's here. One. So this is actually running application in the cloud. This is not on my laptop. This is actually accessing this 3-node cluster in the cloud. And if we see our Grafana dashboard, you can see that we have 3 cluster members running. But again, 3 cluster members is really not a lot. But it is kind of important to understand. And then when we say that these are stateful applications now, so each of these pods here, to-do list 0, 1, 2, each of these 3 pods is both storing data and processing your HTTP, gRPC, GraphQL request, right? It has both Helidon and Coherence bundled together in a single JVM. It runs that, it exposes the ports so you can access your APIs, and it manages the data for you. And it is as easy to scale. Like you would typically, if you want to scale stateless application, all you need to do is scale this deployment in Kubernetes. And that's exactly what we can do here, right? So I can get to it. So we can go from 3 to 100. Right, and I don't know how many resources I have here, but hopefully this works. But it will take some time. So if we look at the Coherence deployment now, you can see that we have 100 replicas, 3 already, and we are in the process of scaling. And if I look at the PVCs now, first you'll see that a bunch of PVCs are pending; they're being provisioned in the cloud. And same thing for the pod. Pods are actually waiting for the PVCs to be provisioned so they can be initialized and started. But you can see that we went from 3 to 100 nodes. And it will take a few minutes for this to shake out, for PVCs to be allocated for the pods to initialize, for the application to start and join the cluster. But in the end, we will have a 100-node application cluster that runs your GraphQL gRPC APIs and stores the data for you. And by scaling it from 3, because if you look at here, we have 6 gigabytes of capacity here because I'm running 2 gigabytes per node. By going to 100 nodes, we'll basically have 200 gigabytes capacity in the cluster for as far as data storage goes. So again, I hope this shows you how easy it can be to scale stateful applications and how easy it can be to write them. And I believe with that, I think we're pretty much at the end. And let me close with these slides, and then we can open it for questioning. So Dmitry, do you want to talk about Helidon resources that are available?
Yes, of course. Yes. So thank you very much for the demo. Once again, this is because of, we are like spread in the world. Usually it scales very fast because Helidon and Coherence are both very fast. Each start is like a fraction of a second. So it's just because of we are away. But if you want to learn more about Helidon, so go to helidon.io. And for the people who like to read, a few of them this way, but this time. But in Medium, we have some long reads and very cool articles which we write about using the technology. Once again, the code is all available on GitHub, so just go there. Whenever you don't like to read and take too much into code, there's a YouTube channel where we prepared a good set of videos for you to demonstrate the usage of each of these modules, technologies, etc., etc. So they're constantly filling it with new content. And whenever you have questions, so helidon.slack.io is your resource to do this. We are answering questions very fast. So Helidon is cool. We accept PRs once again. Thank you.
All right, and for Coherence, our main community site is at coherence.community. So you can find more details about the product and links to documentation, and links to pretty much everything else on this slide there. So if you remember one link, that's the one to remember. Our Medium blog has articles on many things Coherence related, including series of articles that was published in Java Magazine initially, with more details on how to build this particular application that we just showed. Coherence is on GitHub as well, github.com/oracle/coherence. We have our YouTube channel as well with many old and new videos, mostly old, but we're adding content as we go. And then you can reach us if you need to talk to us. The best way to reach us is via public Oracle Coherence Slack. And with that, I'd like to thank you and open for questions if we have any questions.
I hope I wrote it correctly. Please, is this correct in Portuguese?
That's great. Muito obrigado.
Thank you so much.
I think someone is typing a question. Let's see. Well, I think not, but I have questions, plenty. But let's not. So, is there a version of Coherence, the community edition, on cloud providers, on I don't know, Google, AWS, or
you can
Azure?
I mean, is there a managed service?
Yes, a managed hosted solution.
Hosted solution, no. I mean, and it's kind of we are thinking about it. We are working on it. And there will likely be one at some point. I can't say when, I can't say where, definitely in Oracle Cloud if it shows up, right? But, ideally we would like to have it everywhere as well. But the other point is, it is just a library, right? So if you know how to run Kubernetes application, you can easily run Coherence Kubernetes application, right? The operator does a lot of things for you to make it more manageable. But ultimately it's not really that difficult to run. Now, yes, I mean, there are obviously all these systems at scale become more difficult to manage, and it's easy to show a simple demo, and things get complicated fast, right? But the functionality, the features that you need to actually run this in production, they're already there, and they're all open source. So operator is completely open source. You don't, like many of our competitors, they will give you some stuff free, and then when you want to use it, you really need to pay for anything that you need for production. That's not the case here. I mean, you can use everything that we showed here in the demo. Operator, Coherence Community Edition, persistence included, all of that stuff is in the Community Edition. We're not showing any commercial features here.
That's great. Great to see that.
Yeah, but we are hoping to have a service someday, and then you can just build application this way and let us run it for you.
Okay, so Aleks, Dmitry, thanks very much for being here at JNation. Hope we can see you here in future editions in person in Coimbra, Portugal.
That'll be awesome.
So thanks very much, and see you soon.
Thank you.
Thank you so much. Thank you.
Bye,
It was
everybody.
a pleasure. Bye-bye.